Regarding the type of hydrogen, as we said before, the weakest bond is the benzylic, so the easiest to form, and then allylic. And then we have tertiary, secondary, and primary. Very difficult to form is vinylic, though. Allylic, remember, position is right next to, this is your allylic position. Now, the two positions here at the double bond are called vinylic. And this is very difficult to form. So even higher bond dissociation energy than this, so than the primary. So here we will have vinylic. These are terrible. So, and we're going to be using that to determine here what is a hydrogen. I say that we can extract issues and so forth. So I'm gonna give this some positions, just letters, and I'm gonna name this A, B, C, D, E, F, G, H. Well, this is H, identical. Okay, so analyzing that, A is primary, B and C are vinylic. Difficult to form. Notice that B and C are two hydrogens attached to those sp2 carbons there. So similar to that. D here is secondary, but interestingly, this is also benzylic. So should be easier to form. Remember that if you have, I'm just going to draw this to remind you that the benzylic radical is stabilized by resonance, and we can do a number of resonance structures. I had that in another video if you're interested in checking that out. Okay, that's one of the resonance structures. So that should be easy to break. So secondary in benzylic, E is primary, F is secondary, G is tertiary, and H, the two positions are equivalent, these are primary. So, and according to what we said, the easiest one to break them and then form the radical will be D. So let's say from easy to break to, so let's do easy, let's call this weaker bond. So from weakest to strongest, I'm going to rank them. And so we're going to say D then, with secondary and benzylic, so that's the weakest. So we're going to say that this is D. Oh my God, a second. Can I stop that thing? Oh. I hope I can edit that and remove that from. Okay. So in this molecule, what we're going to do now is rank from the weakest to the strongest. And we said that the hydrogen type D then is benzylic, so in the position here right next to the ring, right? So it's benzylic in secondary, so that's the weakest. And then we see what's the second weakest. So the strongest are B and C. So we're going to say they are about the same. This is tertiary, not. So tertiary is good, secondary, primary. So it looks like from what I have here that, oh, well, here, no, we have another interesting position, which is A. A is primary, yes, but is allylic. So notice this is allylic, and that's the case of A. So the is the weakest, then I should be changing the so. Then what follows is tertiary, which I call J. And then we have a secondary position, which is F. And this is secondary. And then what I have, primary, and the vinylic. So it's better the primary than the vinylic. So we're going to say H. And last, we're going to say about the same C. They're not identical hydrogens. but will be about the same energy, and these are the worst because these are the vinylic. So recap, we labeled some positions here, and we trying to see which in this molecule are the hydrogens that are easier to break homolytically, so to form radicals. So the easiest one was the benzylic position, D, then the allylic position, A, then we have a tertiary position at G, then we have F is secondary, H is primary, and is a little better than vinylic. So this is the ranking, and this is how we use. This we will apply to predict products when we are doing radical reactions.